All right, Unit 6, Day 10 is going to focus on solving exponential equations just with word problems. So earlier, we solved exponential equations where you just had the function by itself, and we used our tools of logarithms to solve these exponential equations. But now we're going to do the same thing, however, focusing on word problems. So we have to dissect what the problem is telling us to do to create our equation in order to solve it. So this one says you deposit $500 in an account that pays 3.5% annual interest. How long will it take for the balance to reach $2,000 if it is compounded quarterly? So we don't know what t is because it says how long will it take. So we don't know t, but I'm starting with 500, so that would go in to p, and then we want it to equal 2,000. We want 3.5% interest. That's going to be our R value once we convert it to a decimal. And then the N value is going to be compounded quarterly, so N is equal to 4. So N is 4. R is equal to 3.5%, which is 0.035. So now I can substitute those values in. So 2,000 is equal to 500 times 1 plus 0.035 over 4 raised to the 4t power. Right, so first thing we need to do is get that base by itself. We need to take that 500 and divide both sides by that. So divide both sides by 500. So we get 4 is equal to 1 plus 0.035 over 4 to the 4t power. All right, so now we're going to type, whoops, my parenthesis didn't get drawn in. We're going to type the inside of the parenthesis into our calculator, just the inside. So 1 plus 0.035 over 4. So we get 1.0087. So we're going to call that 1.009. So 4 equals 1.009 raised to the 4t power. All right, now we're going to switch this to log form. So our base of the log is 1.009 because that is what's being raised to the 4t power. So log base 1.009 of 4 equals 4t. So now in the calculator, I'm going to evaluate that log. Now you could use the change of base formula or the alpha window key to type in the log, and you get 154.72, 0.725. So 154.725 equals 4t. And then we divide both sides by 4. So 154 divided by 4. We get 38.68 years. 6.861 equals t. 38.681. 38.681 is equal to t. So it'd be about 38, 39 years for it to go from $2,000 to, from $500 to $2,000. So like I said, what we had to do was basically read and then manipulate to get it to this part, which looks like the equations we did yesterday, where we just have an equation and we change it to log form. All right, example number 2 says you deposit $250 in an account that pays 4% annual interest. How long will it take for the balance to reach $3,000 if the interest is compounded continuously, which means we're going to be using the PERT formula. So we want it to be $3,000 equals 2,500, that's our principal, times e raised to the 0.04 t power, because 4% right here is 0.04. Right, so now we're going to divide both sides by 250. So then that gives us 3,000 divided by 250. We get 12. So 12 equals, not 250, 12 equals e raised to 0.04 t power. Now that we have the base by itself, we can convert it to a log. So it's going to be log base e, but instead of writing log base e, it's going to be the ln of 12 equals 0.04 t. And then in our calculators, we're going to type in the ln of 12. Ln of 12, and we get 2.485. 2.485 equals 0.04 t. Then we divide both sides by 0.04. And when we divide both sides by 0.04, so you have 2.485 divided by 0.04. That gives us 62.125. T equals 62.125 years. So a long time to go from $2,000, or sorry, from $250 to $3,000. So we're combining what we did earlier in the unit, writing these equations, but at that point, we were told what t was and what r was, and we had to figure out either the principal, what we started with, or the a value, the amount, what we ended up with. Now we're able to solve for t. All right, now example 3 says the value of Bitcoin is increasing by 12% each year. If you invested 1,300 in Bitcoin, how many years will it take for the value of your investment to be $23,000? Now, we don't see the word compounded anywhere, so that means we're going to be using the a equals p times 1 plus r raised to the t power, the simple exponential growth equation. The r value of 12% is 0.12. So now we can write 23,000, that's our a value, that's what we want it to be worth, equals 1,300, which is our p value, what we started with, times 1 plus 0.12 raised to the t power. So we're going to divide both sides by 1,300. And we don't have another number in the exponent, so that's going to make this problem a little bit easier. So I get 17.692 equals 1.12 to the t power, or not times t, raised to the t power. So now we can write this in log form. So log base of 1.12 of 17.692 equals t. So we don't need to, like I said, divide by anything after the fact. So I'll go through this one more time. 1.12, and then we had 17.692. So our answer is 25.352. 25.352. So it'll take that many years to go from 1,300 to 23,000. Right now, example 4 says you purchase a new car for $32,000. The value of the car decreases by 17% each year. After 6 years, your friend offered to purchase the car from you for $12,000. Should you sell the car? So because we are decreasing in value, it's going to be A equals P times 1 minus R raised to the T power. Now, you might notice in this problem, we're given T, 6 years. But what we need to figure out, though, is how much will the car be worth in 6 years, and see if it's worth it to sell it for $1,200 at that point. Or you could set 1,200 equal to A, solve for T, and figure out how many years will it take for the car to be worth $12,000, and then compare that to 6 years. I think it's easier to try to figure out, I think it's easier to figure out how much will the car be worth in 6 years by doing this, because we know we can type all this into, we can type this into the calculator all at once. If we do it the other way and say, okay, when is it going to be worth $12,000? 1 minus 0.17, 17 to the T power. And like I said, yes, we could figure that out, but we have to divide both sides by 32,000. Then we have to do the log. But the way I'm doing it on the left, we get the answer in one step. So I'm just going to type that into my calculator off screen. 1 minus 0.17 raised to the 6th power. I get $10,462.09. So if after 6 years, if my friend offers me $12,000, yes, I should take that deal because the car is worth less than that. Yes, the car is worth $10,462.09. Well, so we would be making money. We would be selling it for more than it's worth. And I guess if that's your friend, you may not want to do that. But in the sense of making the most amount of money, yes, we'd want to do that because it's only worth, $10,500 or so, and then my friend wants to give me $12,000. All right, last one. You drink a beverage with 160 milligrams of caffeine. Each hour, the caffeine in your system decreases by about 12%. Assuming you don't drink any more caffeine, how long until you only have 20 milligrams of caffeine in your system? Round to the nearest tenth, so 1 decimal place. So I'm starting with, first let's do the formula. And we know it's that formula because it's not talking about compounding anything. We're starting with 160 milligrams of caffeine. I want to end up with 20, and my R value is 12%, which is 0.12. So now it's going to be 20 equals 160 times 1 minus 0.12 raised to the T power. Divide both sides by 160. 20 divided by 160 gives you 0.125. So 0.125 equals 1 minus 0.12 gives us 0.88 raised to the T power. So now that we have the base by itself, we can rewrite this in log form. So log base 0.88 of 0.125 equals T. So my calculator, log base 0.88 0.125, and we get 16.26, which we'd round up to 16.3. Okay, so it'll take that long for the caffeine to go down to 20 milligrams. So, like I said, for these word problems, you just have to make sure you are careful in setting up your equation and then solving it using the same rules we've been using for exponential equations. So that's it for the video. Thanks for watching, and make sure to subscribe.